Here's another interesting fact that also applies to other helicopters. What we have here, look, if you look at the helicopter blade here, see? This front part is the leading edge, and this part is the trailing edge. So this helicopter spins in this direction, the main rotor blade. According to Newton's third law, the tail will have to spin in the opposite direction. So what does the pilot use? He uses the tail rotor here, but during flight, the pilot can't keep his foot on the tail rotor all the time. And then there's another magic number, again from engineering. What does it do? What does he use? Between 40 and 60 knots, the stabilizers come into effect, you see? And what does he do here? This stabilizer, if you look at it, creates a low pressure area. It's an airfoil in this sense. And when the air starts to hit here, it creates a low pressure area on this side because it's curved, which is the upper part of the airfoil. So what happens then? It creates a force in this direction, making it so the pilot doesn't need to use the tail rotor during cruise flight. Then from 40 to 60 knots, the pilot can even take his foot off the pedal. The rear stabilizer is just that, a stabilizer. So if the helicopter starts to drift to one side or the other, the airflow hits more on the side that's tilted, always bringing the helicopter back to the center. Aeronautical engineering always seeks to ensure that the aircraft is both statically and dynamically stable. The helicopter is a very complex machine, isn't it? We have a rotor spinning in one direction, the structure in the other. We have a tail blade, but the airfoils here on the tail are for that purpose because with them, the pilot can fly the aircraft without having to constantly press the pedal and use the tail rotor throughout the entire flight.